Okay, now we can start. This is the last little bit of that lecture that Alan was talking about. This is linear functions of a normal variable. So our data set is normally distributed with a mean of mu and a standard deviation. So that's all this terminology means. And then we are going to adjust it by applying some formula, a plus bx. And the distribution will stay normal. The new mean will be this and the new standard deviation. Now that looks technical, but let's have a look at an example and see if we can come up with some reason why and to explain it so it's not so difficult. Let's say I have a class test out of 45 in which the students didn't go so well. The mean was 20 and the standard deviation was 5. So if in this terminology, that would be the data set is normally distributed and the mean is 20 with a standard deviation of 5. That's all that means. Now, suppose I'm going to make this test out of 100 by following the following rule. I'm going to double every score and then add 10 to everybody to make it out of 100. So instead of being out of 45, I'm going to double every score and then add 10. So let's look at what that actually does to the mean and the standard deviation. So if we double every score, what happens to what is our new mean? Our old mean was mu, or our old mean was 20. So if we doubled every score, the mean would just go to 40, or 2 times mu. And what would happen to the standard deviation? Well, we would spread out those scores a bit. So instead of the standard deviation being theta or 5, the new standard deviation would be 2 times 5, which is 10, or 2 times the standard deviation. The next bit was, what does adding 10 to each score do to the mean? Well, if we add 10 to each score, all we're doing is moving that graph up. So the new mean would be 50. 40 plus 10 equals 50. What would happen to the standard deviation? If we added 10 to every single score, we haven't changed the standard deviation. We haven't changed the shape of the graph or the spread. Remember, standard deviation gives us the spread. So absolutely nothing's happened to the standard deviation. The standard deviation would stay at 10. So the old score, the old set of scores, had a mean of mu and a standard deviation of, let's say, theta. We have applied this rule to it. We've added 10 to each score and times their old score by 2. So what's that done to the mean? The mean, what we've done is we've added 10 and plus 2 times the old mean. And to the standard deviation, we've just times the standard deviation by that. And that's how he gets this formula up right up the top here. And hopefully that makes sense that when we are timesing scores, what we're doing to the mean, we are doubling the mean, or if we're timesing by 5, we'd times the mean by 5. But adding something doesn't change the standard deviation. Let's look at example 2. Each bag of sugar has a mean of 2 kilograms and a standard deviation of 0.3 kilograms. If these bags are packed into boxes, each holding 20 bags, what happens to the mean of each box? So the mean of each bag of sugar was 2 kilograms, and we're putting 20 bags in each box. So what happens to the mean? Well, the mean is just going to be 20 times 2. 40. Because the mean is just multiplied. What happens to the standard deviation? The standard deviation in this would get more. You'd become less consistent. So that what happens to the standard deviation? The new standard deviation becomes 20 times 0.3, which is 6. So our new, the distribution of the bags was normally distributed with a mean of 2 and a standard deviation of 0.3. The boxes, this was the bags, the boxes would be normally distributed with a mean of 40 and a standard deviation of 6. And that's all that is. The last one was a little bit trickier. Example 3, your students have sat 2 tests. Test A was out of 100 with a mean of 70 and a standard deviation of 10. Test B was out of 20. Average or a mean of 10, standard deviation of 2. And what you're going to do, you're going to weight each test equally, and you're going to make each test out of 50, then add them together to give a yearly total. So this is something that we may have done in the past in lots of different situations. So what happens to the mean? If we're going to halve this score and 2.5 times that score, so they're both out of 50, and add them together, what would happen to the mean? Well, the mean would just be half of the 70 plus 2.5 times the 10. And that would be our new mean out of 100. So this would be 35 plus 25, which would give us a new mean of 60. And that hopefully is at least fairly understandable. It makes sense. What happens to the variance or the standard deviation? That's a little bit more complex. Remember, variance is b squared. So the variance, we're squaring both numbers and then taking the square root. So what we have to do, because test A was halved, the new variance is going to be a half squared times the actual variance of 10 squared plus 2.5 times the second test, and we've got to square that, and the variance or the standard deviation there was 2, so the variance was 4, and that gives us the new variance. The variance of the first test, got to square the weighting and square the variance or the standard deviation plus the weighting squared times the standard deviation squared. And we can work that out on our calculator. And really that is just calculator work. So our new variance is 50. Once I've worked that all out on the calculator, our variance is 50. We don't really need variance. What we're really after is standard deviation. How do we find the standard deviation from variance? We take the square root of 50. And that's going to be 7 point something. The square root of 50, 7.07. And that finishes the breakdown of those lectures from last night. Thanks.